So where we had left off last is we got our foot IK trace working. We had to reduce the radius down of our collision capsule to allow our feet to be able to bounce off the uneven surfaces in the world. But I want something to be able to control this collision capsule, because having a small capsule like this might seem good for the doing work for the feet, but when you're running around in game, it's not going to do so well. And a good example of this is if I walk up to this wall, my camera is clipping through the wall, and my character is already halfway in there. And if I end up hitting the tilde key and I go show collision, and I'll go up to the top option here, I can see a collision. It's kind of hard to see. I'm going to hit F2 on my keyboard here. I'm going to hit the quotation mark key, and I'm going to hit tab so I can actually unpossess and just float around. You'll see the capsule's blocking the wall like it's supposed to, but the character's still going into the walls, and it just looks like a mess. So I want to make something that's actually going to be able to control this capsule for when I need it to expand when it's hitting actors or static mesh objects, or I want it to shrink when he's just running around the world, and I want his feet to be able to operate on the grounds as they should. So I'm going to stop playing there, and I'm going to delve into this character's blueprint. The good thing is we're not really going to have to jump around too much on this character's blueprint. Again, you can always find him by going up to Edit Blueprint and going in. You'll find his blueprint from here. Now, I know using Eventtix can become a little cumbersome in operation after a while, but there's only a couple of things that I'm really going to be plugging into Eventtix right now. So when I need this character to run around the map and see what he's running into, that is one of the things I'm going to use a trace on. So for now, I'm going to run this through an Eventtix, and I'm going to bring this down, and I'm going to add a reroute node for here. And I'm going to need some space to do some operation in this, but I don't want this to be a huge mess as it's slowly starting to become. So I'm going to end up doing collapse graph nodes. And this is kind of cool because I can embed some of the information here. It's almost like the same way that information gets embedded in functions, but really it's just collapsing it down into a segment. It's like putting a sticky note on top of your monitor in a way. So I'll right click on this and I'll do a collapse nodes, and I'm going to call this collapse graph the adjust capsule component. And you can come over here and you can add any description you want, and you can even change its color. And for the input pin, I will change this. I'm going to change this from input pin to Eventtix, so that I know that this is actually an Eventtix that's driving this number. So let's double click on this new node collapse that we made, and let's begin editing. I'm going to get rid of this reroute node here since I won't need it. And the output, I'm not going to have anything flowing out of the output from this graph, so I'm just going to bring it over near the input so I know where to find it in case I ever do need it. And let's begin writing this. So how I want to set this up is I want to do a detection around from, let's say, around his knee area to the top of his head. And anytime he runs into any objects in the world, I want to be able to allow the body to have the capsule expand, block everything around him, except for the feet. Because if the feet run into any objects, I still want the feet to be able to do their IK work against uneven spaces. So I don't want this capsule to expand past the feet. So let's jump back to the blueprint. And the first thing we'll want to do in order to drive this is we can use a tracing channel. Now, if we did this just by a line trace, we'd have to do, I don't know how many line traces around this character in different directions just to get it to work. But luckily, work has already been saved for us. So we can do a sphere trace by channel. And let's just plug something in real quick so we can see what this looks like. So our draw debug type, let's turn this on for one frame. Since this is an Eventtix, we're going to be seeing it every frame an Eventtix goes on. And we need a start, an endpoint, and we also need a radius. By default, our capsule component is set to a 34 radius. I'm going to give this a little bit of buffer room. I'm going to hit Control Z to undo that value there so it's set back to what we have it now. And I'm going to give this about 40 because I want a little bit of buffer room from the actual maximum size if I'm going to make this capsule. So that way, before the character completely hits it, by the time the capsule expands, the capsule will be fully expanded, hopefully by the time the collision starts to happen. So we need a start and end point for this. So the start point's actually going to be asking, okay, where is the start of this sphere going to be, and how far out is it actually going to go? So let's base this off of our actual actor that we're using. So what we can do is we can get the get actor, I'm sorry, what is it? One more time, get actor location. And from this, we actually get a vector. So we're already off to a good start. Now, if I just plug this in right away, since we have one frame on, we can actually see what is going on with our line trace. We'll see that we have a spherical line trace inside the character. And by default, it's just going to go with what the actor location is. So let's get some values in there to drive it to get a little bit more of a shape for that trace. I'm going to break this out in two different ways. So let's break this vector. I'm going to copy that because I'm too lazy to type that back in. And then I need to make a vector from this. Copy that as well and bring that on up. So this will control our endpoint, and this top part will control our starting point. So to be able to make that a little bit more customizable, our X and Y was fine for both our start and our endpoints. But I want to change the height of our capsule. So I'm going to make that about 50 units in the Z-axis. So if I take a look at it again, I'm actually going to plug the Z right into here as well. We play this again, we'll notice our capsule has actually gotten a little bit bigger. That's great. So let's move this down a little bit so it's not too far above his head. And we don't need it to be really far down, so I'm just going to minus that from a float. And let's do it by 10 units. Compile it, and let's play it. And it's moved down a little bit, so it's around his knees. Cool. So we're pretty much ready to go. So our line trace is set, and we have an Eventtix that's driving it. So now we can begin to find out, okay, if we hit something, we need to be able to take the radius of our collision component. So let's grab our collision component and bring it out. And I want to change the size of the radius of this collision component. So what we can do is we can set capsule, let's set radius. And it gives us our set capsule radius. And I'm going to want two of these because I have specified values. So we have our default radius, which will be set to around 8 at the bottom, since we're relatively around that. And then our default by radius, which was, I believe, 32. So anytime our radius hits something, let's find out what's going on. Let's make sure this trace by channel is working first of all. So let's bring in a branch and let's plug that right into condition here and into the branch, and let's do a print string. And with this one print string, I'm going to bring this down and I'm going to change the duration of this from, instead of 2 seconds, to 0.01. The reason being is because that way I'm only seeing one print string instead of like the entire side column of my screen filled up with them. So I'm going to bring that one up. I'm going to change it. Let's copy this and bring it up below. And I'm going to change this from blue to red. Plug that false down there below. And for the return value of this, I want to be able to know if it's true or it's false if it's hitting anything. So I'm just going to bring that right in, drag it right into the in string. Let's compile that and let's go ahead and play it. And we'll see right now that it's on false. And to better see this, we already have we have our debug trace on, so we can always see it. I'm going to go to unshaded mode with F2 to be able to see this a lot better. So right now we are in false, and anytime we run around and we hit this wall, now it's coming back as true, and it has a green detection sphere going on telling us, yes, we've hit something. There's something active going on in this. So awesome. Our sphere trace is working great. So I can get rid of these print strings for right now. And now we have something that's going to drive us. So I know if it becomes true, that means it's hitting something in the world. Let's grow our radius up to 32 units. And let's make sure if we're not hitting anything, let's just go back down to 8 on the radius. Let's plug that target in for our capsule component. Let's compile it. And if we play it, I'm going to get rid of that debug so I don't mistake that with the actual capsule I need to see. So let's put that back to none because we know our sphere is working for tracing. So now Let's go show collision. I hit F2 to be able to see my collision better. So now if I'm running around and I hit the wall, my collision now grows. My character is not intersecting the wall anymore. Awesome, that's great. So our collision will actually dynamically change as we're running around the world and running into things. Now, however though, this would be a great place. You can stop from here, you can go on and do what you want from this, but I want to be able to make this lerp instead of linear interpolate, so it actually doesn't just snap and pop. Because what if I'm running through the air and, you know, I won't see it there, but the stairway here is the best example that I've run across. So if I go up to about that, you see where it's just popping me right off the stairway. It just seems a little bit awkward. It even happens when you have other objects. But let's do a linear interpolate, set this up really quickly. It's not too much, but the great thing is it'll actually give us a more smooth transition from when our capsule needs to grow and shrink. So I'm going to bring this over here. I'm going to give us a little bit of room. And for this, let's actually bring this over as well. And let's do a couple of things. We're going to need about 3 different floats. So let's make 3 new variables. And I'm going to give this new variable to be a float. And I'm going to put it in its own category of, we have animation handlers IK. I'm going to add that to animation handlers IK, but I'm actually going to edit the category it's in. I'm going to change that to our capsule, or actually let's just change it to component. So we know if there's anything with handling of animation or changing a linear interp, it'll be our component. Okay, so let's duplicate this 2 more times. And let's start naming these. So the first one I'm going to name is, I'm going to call this one our capsule components f space interp value. This will be our value that's actually changing as we're interpolating the size of the capsule. Next one I'm going to call this the capsule radius max. I'm going to Control A, Control C, just so I copy that name. F2, I'm going to paste that, and this will be minimum. Now, I like to give tooltips on things, so that way if I read over things down the road, I know exactly what is going on or what these different objects are doing. So this will be the minimum radius size. Minimum radius size of our capsule component. I'm just going to copy all that, and I'm just going to change the beginning of that wording to maximum. Okay, so from this we need to grab both our max and our minimum. And our maximum size, I'm going to set mine to 32. Let's compile that so I can change the values of these. This makes it easier in case you need to change any of these values. If they're placed all over your blueprint, just go right there and change it. And our minimum size is going to be 8. So we want to do a select between these two. So let's select a float. Let's plug our minimum into B. And what's going to happen is, like this branch we had here, this is going to be doing the same thing in a way, but it's actually going to be selecting the float whenever the value of this changes. So what's going to drive that, we'll just bring our return value being hitting anything, it'll be pick A. So if it hits something, it's going to become the maximum size of 32 in our radius on our capsule collision component. And now we'll add a interpolation for this. So let's grab our capsule components. Let's find our capsule radius. And I'm going to drag this out. I'm going to go f interp 2. So whatever the current radius size of this is, we want that to be the target that's going to be going for these. Well, for our delta time, we'll get delta seconds. And I'm going to change the interpolation size or speed to about 5. So I mean, it's going to be pretty quick. It's not going to be very slow. but it's not going to pop and snap like it was before. And this is going to drive our capsule component Eventtix value. So we'll set that, and this will be up here, and let's set it just before the branch. So I'm going to control click drag that pin and drag it over, plug this one right into the branch. Okay, so let's organize this up a little bit. I'm going to drag this a little bit below so I can see the full line here, and I'm going to comment this in, says change size of collision component, or capsule component, excuse me. Alright, so now we have something that's going to be changing our capsule component. Instead of popping, it's actually going to grow it. And then we just need to feed these values into our radius for whenever these get changed. So I'm going to make a little bit of room here. And let's bring that on down. Whoops. Let's get that. Go. And let's go ahead and we'll just set this right in. Now the reason I paused there for a second is because I was looking over at what I had done before, and this was actually to explain another issue that was going on that hopefully I can show you guys. So let's do our show collision again. And because I already know I've done this a few times, I can just hit the tilde key, go up, and there's show collision so I can see what's going on, F2. So now when I walk over the stairs, my collision component should hopefully grow. There it goes. And see, there's the problem I was having before. That I actually will show you guys a little workaround for that to make it not as jumpy as it is right now, but it actually will gradually grow when we walk up to objects. So it really won't pop like it was doing before. Now we need to handle something to be able to not have this crazy jittering that's going on whenever our capsule is trying to find the difference between if we're in the air or if we're not. We can do that by setting up another bool statement to say when this capsule needs to grow, let's make sure it grows all the way before we decide to actually shrink it back down again. And for that, we will actually make another variable, and this one's going to be a bool. So let's add a variable, change its variable type to Boolean, and I'm going to call this bool the capsule components size adjust question mark. And for the description of it, I will actually give it let's say capsule component is adjusting its collision radius size. So that way is the capsule component adjusting its radius size. So let's add that into our component area and our category so all this is together. And let's go ahead and set this twice. Let's set this twice. And we'll need this to be driven beforehand by a branch. Whoops. So let's hold down B, click on the graph there, and let's bring true and false. And let's set this one to true, and this one will be to false. And we'll plug that right into set capsule. Now let's bring this one into false. Okay, so now we need something to drive this. So what's basically happening is this is actually going to be set to true when it's growing. And once it actually finds out if it's true or not, and if it's not hitting anything, then it will shrink back down and it'll be setting this to false. So we need something to drive this. Well, we can actually use our capsule component F_interpolate value to drive it. And using that, we can actually compare it to something. So this value changes as it grows, but this value is static, which is our max. So once it reaches its max size, then it can become false if and only if we're not hitting anything. So we'll need to say if our capsule component is less than or equal to the max size -5, just so I can give a little bit of leeway for checking so it doesn't become 100% as the other one. Alright, so we have that set up. For organizational reasons, I'm just going to double click this and bring it in down there. Okay. And let's comment in our value here, so staying organized as best we can. And let's call this the adjustment of capsule components size and setting of adjustments. Cool. Alright, we're almost done here. So we also need this value to be driven beforehand. So let's bring our entrance up here and let's bring in another branch node. And all we got to do to plug into this branch is our capsule component adjust. So if it's true, our Eventtix is going to come in. If this is true, then that must mean that our capsule component needs to still change, is still in the process of changing to its maximum size. So it'll come up and it'll actually continue to keep increasing the size of the radius until it reaches the max size that it's set to. However, it is not the same size, then we need to keep tracing and then keep on setting and then see if we can change the size or not, or shrink it back down if we're not hitting anything. So I'm going to add in a little note on this spool here, or this branch here, just so I know what it does. So resized capsule until at set max size. All right. So now if we compile it, let's save it too, and let's see what happens in the play area. Hit tilde key, I'm going to show the collision, and F2 to go to unshaded mode. So if I run up to the stairway now, you'll have a little bit of bouncing, but it'll gradually scoot the character over. So it's not going to be doing a really bad jitter, but I'm still doing some research on how to get this to work a little bit better, because something like that will cause a little bit of craziness in terms of the player. Now, normally in most levels you will never really run across the stairs set up like this. It's very rare, but in order to alleviate something like that, in order to alleviate something like that, you can easily just make your level geometry a little bit different. So I'm going to hold down Shift and Alt, and I'm going to bring this over here along with this piece just to kind of show you what we've kind of set up. So set this at the edge. And I'm going to rotate this about, let's say about 40 degrees. I'm going to make it actually the same direction as the object itself. So local. Get that down a bit more. So now, hold Alt and Shift, bring it over. So now we have some cool little stairs that we can play around with. So Alt P. And show collision, unshaded, and our character can just walk up the stairs, and he works just fine. So the capsule is doing what it's supposed to do. That's why we didn't have the debug capsule, the line trace capsule, go all the way down to its feet, because if that was happening right now, his leg trace wouldn't be working. So if we're actually standing on this thing, his leg trace is doing exactly what it's supposed to be doing. Now I'm still working on getting the pelvis to be able to go up and down for the middle of his body to do an adjustment for that. But that's how you can get your capsule to dynamically change for you to be able to do a little bit better management, and that way it's not clipping through the walls anymore. But it's just going to act the way it's supposed to when rotation in the world. So that might have been a little bit longer video to go through, but hope you guys enjoyed it, and I'll see you in the next video.